بيجي يشرح عملي بس بصوت شو مش شرح.
بيعمل حساسية. أنا مقاتل أكيد من شمس.
خلصنا من نعمل الخاتم.
في نملة خاتم.
وبعت لإخوانك.
Okay, and then the basin itself, the Permian Basin, is off over here to the north. And what is happening is during this time period, when we're in the late Permian, all the way up into the early Mesozoic, probably up into the Jurassic, this area is in a transition zone, meaning that we're not all the way underwater. Sometimes the level of the Permian Basin goes down a little bit, and we're this fluvial system where all the sediment's being drained off the uplift. The mountains are off in this direction, and we're draining the sediment into the basin. And so what you're really looking at, y'all ever heard the term like a flexural basin? Yeah, watch that little guy. He'll sting you pretty good. Now, would you say it's been transported a long way or a short way? Like what minerals do you see?
Long way.
Long way, right?
Yeah, is small.
Yeah, they're small. And in which mineral are you looking at most likely?
Synthesized.
See it sparkling, the little ones? There's only one mineral sparkles like that.
Mineral?
Has a hexagonal form.
Quartz?
Quartz. Very good. So that's what you're looking at. It's a quartz sandstone. Alright. So now what we want to do is, you see how some of these things are eroded? You want to find a spot that's kind of original, to where it's straight. It's like right there is a good place. Or if you're looking at something like this, there's multiple methods. You could take your book, lay it down. You remember the strike and the dip method we showed you yesterday? Where you take your compass, you open it up, and you get it dead level against your book. Remember this method that we did? To where you determine where it comes level into your book at? But see, now we got a problem, because you got this here. We don't quite have enough movement. So sometimes you gotta like take your book and interpolate the way the bed comes out.
Yes.
So y'all have done that? Okay, good. So we would have it come out, and then you can read it like up under here. See, so I got this thing striking at 0.18. Okay? So it's striking this direction, and the dip is this way, straight down. And so I got my book just right.
The plane of the compass must be perpendicular of this
Perpendicular to this plane. Perfect. Did y'all hear what she said?
Mm-hmm.
Alright. And so then once you figure this one out, you know, there it is, the inclinometer right there in the center. So you read that as what, 20 degrees?
20, yes.
20. So we got a 20-degree dip with a 0.18 strike. Okay? Now, and you would say that it is dipping, you know, to the west. So when you write that in your book, what I want to see y'all do, can I borrow a pencil from somebody? This is your book, right? And so you write the strike, and then you do the dip. Okay? So it'd be 0.18 degrees, 20 degrees west. Make sense? And for every one you do, you write it down like that, with the general direction. Alright. And so what do y'all say? There's your book bag. There's your book. I think that's your compass.
Can I get a group down here with Hen, because Hen can't climb up?
Oh, I'll come down.
Okay.
And so y'all can scatter out with your compasses, working like groups of 3, and then John and I will come along, and we'll help you out with this stuff now. And so let's just spend like 20 minutes doing this, so you can kind of practice. All right?
Okay.
And then we'll go do discharge at a different side.
46.
Can I lean in for a second?
It's better.
Yes. Yeah, so it's about 0.8 2. We'll get James to check that.
We can see the another direction for the north. We read it this.
Right, because of the
Yeah.
orientation, because James was explaining that you do the top half, basically from 90 to 270.
Yeah.
Is that right? Yeah, 90 to 270. And because the north arrow is pointing beyond 270, that instead you take the reading on this upper half of the circle. So it would be 0, 8, I believe. Am I reading that correctly? 082. Let's check with James and make sure.
Yeah.
I was trying to pay attention yesterday.
Level against the perpendicular in the book. Right there.
Yeah.
Now you read it.
This?
Yeah.
16.
Okay.
16.
16 50.
058.
Yeah.
Right?
050
058. 58.
58
58.
8 0
Right?
058.
You got that.
Yeah.
And then the dip is perpendicular to that.
Yeah, it's
And then that's where
55. Yeah.
Right.
This is the dip
Right. In this direction.
in this direction. Yeah.
Now, in some cases, there's some tricks that you can do, like on stuff like we're standing on, where we can't really see where the dip is or the dip direction. You can take a drip of water, put on your book, and it'll run in the direction of the dip. Okay, and then that'll help you figure out how to measure it from there. It kind of gives you a starting point. Thank you. Here you are, sir. I think this is your book.
Alan.
All right, so let's practice, and then you can practice here. You know, they're going to be different. It States Geological Survey uses, and what it does is it's a system as the water picks up through here, and it pushes this around, and it causes this to click. So there's a click that goes through, and we set up a set of earphones. The click is picked up all the way through the rods, and there's a setup up here where we put these headphones to right here, and then you listen to them. Alright, and you're going to have to count the number of clicks over like a minute or 30 seconds. So we have these timers, and then the number of clicks you have for a set time, you correlate the discharge off this matrix. And you have to write every bit of this down in your book as you do it, or the data's bad. Alright, now this one's a lot more complicated to use, but it's still the preferred method by the feds, just because it makes you slow down enough to where you take great data. Alright? So let's get this one together, and then the other one that John has.
Right over here.
You want to tell them about that one, John?
I don't know how this one's working.
It's electromagnetic induction. I mentioned it briefly in class.
Okay, so you did it in class.
Yeah, I talked about it in class. But if you look at the rods are pretty much identical.
The rods are the
except
same.
that has the outlet for the earphones. Right. So each of these rods, if you remember, I mentioned that it was graduated in tenths of a foot. So if you read this, the lowest reading you can get pretty much is 0.2. And then that's 0.3, 0.4. When you have the double line, that's 0.5. 0.6, 0.7, 0.8, 0.9. The triple line is 1.0. So the triple line is 1 foot, the double line is a half foot, the single line is 0.1 feet. And again, we'll do the conversions from feet to metric. Now, what I do, I'm not sure whether this is standard practice with USGS, but it's what I do, is to infer to 1/100th of a foot. So if you see this, for example, this line I'm pointing to, somebody tell me what that depth is in feet.
Here to this day is perpendicular to the water current. So water current's coming straight at it. That way you're perpendicular to your cross section, I'm sorry. And so we'll do the same thing. We'll measure a cross section across. I like to measure every 6 inches. Or, you know, we can go every foot if you'd like.
6 inches is a half foot. And remember I said it's good to take more measurements than you need, because you want to make sure that you have no more than 10% of your flow through one individual segment. So if you do it at 6 inch or half a foot, increments, that's usually pretty good. Now, over here, that's going to be interesting. I don't know how wide it is there, but it looks like it may be 10 feet, and it's moving very fast. I usually don't do it any narrower than half a foot. I sometimes do 0.25 feet or 3 inches, but then you're kind of, you know, very narrowly stepping across, and then I think there's more chance for error.
It's also in meters. These ones I have, we read it.
I'd rather do it because this is, the tables in meters or the...
Well, I have the tapes written.
Now let's go ahead and do everything in feet and then convert. It's easier than having mixed units.
Alright. Well, what happens with these, you see these screw sets that you have, these have to be tied. This here is a little screw set that's linked all the way up to this headgear. And so when you get it, you put this headgear on your head, and you can hear, as this makes every rotation it makes, you ready? Every rotation it makes, you hear it go click, click, click. Alright? And so as it's going, you're going to have to set times. So like what John has here, are these matrix are developed. We're using the standard one, so we're using this yellow chart where it says the standard one. We're going to have time in seconds we measure. So like normally I like to go for a minute, but we can go 30 seconds if y'all like. You really got to go 40 seconds before you can get a good idea on how many revolutions it's made. So let's go for a minute. So somebody's going to have to run this. So we'll start. You'll start counting the number of clicks. It'll go a full minute, then you stop it, and say it made 50 revolutions in that 1 minute. You come over here, you read however many revolutions you have. We had 1 minute, so we'd be down here at 60 seconds. Revolutions, we'd have 50 revolutions, we'd come down, and this is your discharge. There you would see. Alright?
That's the velocity.
The velocity, right.
Not the distance.
And then we use that number later.
Okay, so what I would recommend with the Marsh McBurney is for this, rather for the standard meter, instead of doing a column with distance, depth, and velocity, you do a column with distance, depth, and revolutions, and then you go back and write the velocity down.
And the time.
And the time. Well, yeah.
Number of seconds.
Number of seconds, too. I was assuming that if you do it for a minute each time, if you standardize it, then you don't have to record that. But I think James is probably right. If you're working with that meter, you want 4 columns: distance, depth, revolutions, and time. And then you can go back to this conversion table, whereas it's all done automatically in here.
So I guess we have 2 different ways to learn today. And so, you know, it's going to be a fun day. The one thing you got to remember on these things is they have set screws down here. It's not good to leave this free flowing and only use it, like you don't want to spin it, but you see this little set screw. Thank you, John. You want to set this here to where it doesn't spin. So you spin this down and then see it stops it. Alright? And that keeps it from getting harmed when we take it apart.
Right, that's when it's in the water, you don't want that screwed down.
So,
you want it available to rotate.
When it's in the water, you spin it up and then you oil it. I already oiled it with this white oil, meter oil they call it, and that way it can spin freely and it doesn't get water up in the little bearings.
Right.
Does it make sense? The method on this is identical.
Yep.
It's
same
still
rods.
Same exact rod. And so I think we're good to go. Now we need to scratch a cross section.
Yep. See what we're doing.
Yeah. You got that?
Right, so these represent feet adjusted for the 60% rule. So what I do, this marking here is tenths of a foot. So 0.0, 0.1, 0.2, and so forth. So 1.60, I push this button here, lift this rod, and I am reading 1 here, and then 0.60. So that is adjusted
0.6, yeah,
to the proper depth. And if you look at this, this is about...
Let's get the tape.
Yeah, well, get the tape, that's right. You should be able to measure in the distance from here to here should be 60% of the total distance from here to the ground.
Okay, this is the detection in...
This is the sensor. That's the electromagnetic sensor.
Yeah.
And if you look, there is an arrow on it that says flow direction. And that arrow is pointed away from the fat part of the sensor. So this should be oriented pointing upstream so that flow is downstream. Yeah.
So somebody calculate what 0.6 and 1.6 is.
Yep.
And then we'll compare.
What is 0.6 times 1.6?
60% of 1.6.
1.6 times 0.6. What is 60% of 1.6?
Do 1.6.
Nope, that's 50%. So,
1.4.
nope, do the math in your head. Multiply 0.6 times 1.6. And then if you see, I turn this on, and that's the readout initially, and then it reads, it gives me a meters per second option, it's just not programmed for meters per second right now. So it will start to read in feet per second once I stick it in the water. If you see it's got this dash, 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 it's not reading anything because it's not in the water. Now, once I put it in the water, sometimes it will give me flow at a negative velocity. So anything that is less than 0, I call 0. So I will call out numbers. I may occasionally, if I'm not paying attention, I may say NA. In English, that is not applicable. That means disregard. So, right. So more often, though, I will simply do in my head, when I see that it is less than 0, I will say 0. So again, if you remember what I had on the board, you'll have 3 columns. Distance, which is width in feet across the stream, depth in feet, which is what I measure using this part of the rod, and velocity, which is in feet per second. So let's go ahead and get set up. This operates off 2 what we call D-cell batteries, 2 large alkaline batteries. And it's good to have spare batteries, because I have been in the field where this starts flashing. There's a little light that says low bat, which means your battery is running out. And you don't want to be in the middle of one of these gauging measurements and all of a sudden your instrument dies. So having spare batteries is
Your standard rating table for double A.
I guess it's pretty stagnant out there. You could go like 2 or 3 good intervals. Yeah, no, I think that's the way to do it.
That'd be great.
I'm guessing the flow here is going to be really asymmetrical.
You guys get out there. While we're in hydrology, if you get wet, what are you doing on the bank? Never done the discharge? Did you? Go for it.
يصير عندهم مصورة. أحسن.
Distance.
Yeah.
3 feet. Depth is 0.49. Velocity, 0.13. Wait. Velocity is fluctuating, so we have to wait till it's stabilized. Let's call it 0.13.
0.13. Yeah.
Our first measurement we had 4 feet.
At 4 feet distance, depth is 0.86.
0.86.
I didn't adjust the depth. Okay, let's try it
I'm gonna unload the lunches into your truck in case they need them, and I'm gonna go get some maps and lunch for us.
Sounds good, thanks man.
Okay. John, I'll see you in a minute. Bye guys, I'll be right back.
Right now.
Alright ladies, velocity at 4 feet should have been 0.16. I left it at the previous depth, I didn't correct it, so now it's correct.
Yes.
Yeah. Yes, I can 0.49.
Velocity 0.13.
0.13, yes, okay. Oh no, I'm sorry. That's the one that just changed. That should have been 0.16. At 4 feet, velocity is 0.16. Yes, that's correct.
That's the amount of time that would probably
زينة من كده قفلتيها؟ قفلتيها؟ لا سجل سجل اوه اوه
So that's what we did at 4 feet 3 inches. Now we're going to 4 foot 9
Okay, 0.14 is the velocity at 5 feet.